Hello, in this session, we'll see a question on finding the inverse of a matrix by adjoint method. So, let's say we have a matrix of second order with the elements 2, 3, 4 and 10. So the first thing we have to do is finding the minus of the element, then cofactor of the matrix, and then transposing the matrix of cofactors will give the adjoint. Dividing it by the determinant will give the inverse of the matrix. So A inverse is given by 1 by determinant of A times of adjoint A. So let us start with finding the determinant value. This will be 2, 3, 4, 10, and this is 2 times of 10, that is 20, minus 3 times of 4, that is 12, equal to 8. Now minus of the matrix will be M11, and this will be, let's say we are drawing this matrix here 2, 3, 4, 10. So for this element, removing this row and this column, we are left with only element 10. So minor M11 will become 10. M12 will be, leaving this column and this row, we are left with only element 4. M21, leaving column 1 and row 2, we will be left with only element 3, and minor M22 will be simply 2. So matrix of minus will be a 2 cross 2 matrix with the elements 10, 4, 3, 2. And of this we can see that this position A12 and this position A21 are the odd position, where the cofactor will be negative of the minor. So matrix of cofactor will be 10 minus of 4 minus of 3 and 2. So this is 10 minus 4 minus 3 and 2. Now adjoint A is transpose of matrix of cofactor. So this will be 10 minus 4 minus 3, 2 transpose, and this comes out to be, interchanging the rows and columns, this will be 10 minus 3 minus 4, 2. Now A inverse will be 1 by determinant of A times of adjoint A. So this is 1 by 8 of the matrix 10 minus 3 minus 4 and 2. Taking this 1 by 8 inside, we can write it as 10 by 8 minus 3 by 8 minus 4 by 8 and 2 by 8. So this is the inverse matrix we were looking for. So this was matrix inverse of a second order matrix. Now in general, what we can do sometimes to save some time, it can be helpful, it can be of good use, that if we say a 2 cross 2 matrix is having element A, B, C, D, then directly we can write that A inverse will be 1 by determinant of A times of the matrix where A and D are interchanged and B and C are introduced with a negative sign. So this is 1 by AD minus BC of D minus B minus C and A. We can apply this for a second order matrix and we can verify for our question, which was matrix A with the elements 2, 3, 4, 10. Determinant of this matrix is 2 times of 10 minus 3 times of 4 equal to 20 minus 12 equal to 8. So comparing the elements to be A, B, C, D, we can see that this element 2 and this element 10 should be interchanged. So this is 10, this is 2, and the elements 3 and 4 should only be introduced with a negative sign. So this is minus 3 minus 4 whole divided by determinant, which is 8. So this is nothing but 10 over 8 minus 3 over 8 minus 4 over 8 and 2 over 8. So this is our A inverse, and we can compare it with the one we found with the adjoint method. So these are all same. So this is how we can find the inverse of matrix using adjoint method, and for a 2 cross 2 matrix we can also apply a shortcut if required. Thank you.